We have a circle. One resistor here, one resistor, there's a one resistor. Then from here, just it's a good problem to remind you, capacitors should be shorted nine by eight. So everything okay. The cell will be there's a cell of V 12 volt. All are 16 ohm. All are having same R. Look at this. It's a Wheatstone network. So can we remove these resistors? Potential. I think I took potential at A, potential at D is equal to E. A, where is the B? B is here. C is here. This is E. VD equal to V and equal to B that also. So therefore these two will be parallel. These two are parallel. This will become parallel. And all these four will be parallel. These four resistors will be parallel. All those which are parallel, I'll shade. They will be parallel. And they'll be in series. And these two resistors, you can remove it. So 16, 16, this will be 4, 4, 4 by 16. So the equivalent circuit will be, oh, wait. Between AB, no, it is asking, not C. Not this one. The cell is connected at B. No, between these 2 points, you have to come. I think you have to simplify circuit here. I'll change colors. I'll be giving, now come for this. These two are in parallel. These two are in parallel. The cell is, you can, if you want to directly bring the cell here. These two are parallel, these two are parallel. So the next set of diagram will be, we'll have this one. So 16, this will be 8 ohm. 6 ohm. 16, 6. All are 16. Yeah. Just make observation. Everything, all the resistance are 16 ohm only. Yeah, this will be again here we'll get 8 ohm, 16 ohm, 16 ohm. This is across, circuit will be AB. The cell is connected across AB. Anybody answer? Reading of ammeter. Ammeter is, where is ammeter? Ammeter is here. A, this is D, this is C, and this is E. Check it now carefully. We have to redraw this circuit. D and E are at same potential. Will I agree? D and D are at same potential. Shall I write directly? VD equal to V. From current distribution, if I divide this current, say I1, this will be I1. So from that, VD equal to V. Once VD equal to V, so you redraw that circuit. So this everything will appear. Oh, something is asked, a very lengthy question. This is cell. This is AB. So this will be 8 ohm, because I'll join them. So this will become D comma E, and this will be 16 ohm. This will be 16 ohm. This will be 8 ohm parallel to 8 ohm. Okay, this should be, this is the point B, no? Okay, I think now we can solve it. Please do notice, there's no other way. We have to redraw the circuit. 8 ohm, 8 ohm, this will be 4 ohm. This will be 8 ohm. This will be 4 ohm. So we have to get the reading of ammeter. The ammeter is here. Anybody value? D and E are same, but DE is not equal to VB, that one. There'll be flow of current. So you can't remove these two resistors. Reading of ammeter just after key is closed. I don't have answer. I just picked up a question. This is. Anybody? 4, 4, 20, 20 parallel to 8. Then, okay, the simplified circuit, I'll put it. Check. 6 ohm, 4 ohm, 8 ohm, 20 ohm. This is what the circuit, next step simplification. 20 and 8 parallel, that you further effective, and that will be in series with 4 ohm, and that effect will be in parallel with this one. Okay, can you work out? Anybody, if answer is there, okay, or else I'll go for next one. K is closed. Just after key is closed here. After long time, I think it's very easy, no? Where all capacitor, you have to put it as open circuit. I'll go for the next part. Oh, no, please. Somebody gave answer. 2.5, yeah? Okay, 2.5 ampere. Yeah, fine. Let me add one more page. I'm going for second part of the problem. In the second part of the problem, so what is the effective circuit? Where all capacitor is open circuit. Okay, drawing circuit again, we have to. The first part only. After long time. after a long time. So there'll be this capacitor, this resistor I need not to do. This will be, so here this resistor will be there. Here open circuit. There'll be a resistor here. And the cell, let it be. Okay, this one. This is all 16 ohm, 16 ohm. There's a point A, there's a point B. I think again redrawing circuit, no? So here we have resistance. Okay, redraw the circuit. Between AB is asking. So there's a point. Again, we have to redraw the circuit. So this will be 10 ohm as it is. Sorry, 16 ohm. So these are the points. AB, I'll bring it. This ammeter, 16 ohm. From A to okay, I'll arrange things like this here. So it will be what to do this register. So this part of the ring, will there be any flow of current here? Anybody wants to answer? Oh, will there be any flow of current in this part?
Sir, there is one more resistor, sir.
16 ohm, no? Oh. Will there be any flow of current? There's one more, no? Between B and this. Okay, I connected it. Yeah, thank you. And now there'll be flow of current. Without this resistor, there would have been not that one. So because of this resistance, there'll be the current what happen will come here. Current will branch. Yeah. Anybody resistance of this? Shall we put these two parallel 16, 16? So how much you get? Say you not to do anything. I think it's very simple. I'll redraw the circuit. This 16 will be 32, 32 parallel to 32 ohm. And that will be 16, 16, the 32, and the 32 again. So how do it appear? It will appear like a parallel with this 16 ohm. So next further circuit will be 16, 16 will be 32. Okay, this will be 32, 32, 16. So this will be next circuit will be 32 ohm, 16 ohm, and this is cell. So now you calculate what is the current through this one. No need again, say this will be how much? 12 volt. Calculate current here and here, add up these two currents. That should be the current that is flowing through the ammeter. So what is the current through the ammeter? I1 plus I2. So solve this. Let me go for it. It took more time, no? Can be asked in exams. Charges in each capacitor when steady state is achieved. Oh, where is the steady state circuit? This is after long time or at steady state. Okay, again, further is troubling us with some more data. No, steady state means what shall I do? I should find out the drop across all these capacitors. So I think definitely. So here these things. So what shall I suggest you? So you'll be knowing current I1, no? You'll be knowing this current I1, this particular current which is flowing. I think we should at least here we should trace the current here. If you trace the current here, yeah, the drop across this will be the drop across this capacitor. The drop across this will be the drop across this capacitor. So this drop, what you calculate, will be drop across this capacitor. And this drop, what you calculate, drop across this capacitor. But once you know this drop, okay, then or else you write loop equation like this, you'll get a drop here. Or else write loop equation, you'll get a drop here. The same idea. And this drop has to be calculated. I think what I suggest, what you do for this capacitor, it'll be same for this. Am I right? And what you do for this capacitor will be same for these three. And these two, what you do for this capacitor will be same for this capacitor. Somebody has commented, let's see, 32 by 2. I think our circuit, yeah. Okay, can you work out here? So I'll just leave it. So how to calculate this drop? Okay, again, you have to come back from here. 32, this will be 16 ohm. That 16 ohm, I think this will be 6 volt. The drop across this will be 6 volt and the remaining anybody, can you tell me the drop V, because problem will get over.
Or we can find the net resistance and then find
Don't do all this, very lengthy. Yeah? This will be 16, no? So this 16 volt will be shared. So
6 and
I'm
6.
6 volt it is. I'll write in red color, 6 volt. Okay, this 6 volt is what will be shared and this will be 3 volt. Shall we write? Okay, if you know 3 volt, you can bring this one. What is the drop here? 3 volt. Is forcing us to think a lot. That is the problem. Okay, once you know this 3 volt, okay, now you can calculate this particular voltage. Call some V1, whatever you want, you can call this one, VA or VX. Write loop equation, and you know this current I1. Write loop equation. So this should be -3 minus Vx plus 6I1 equal to 0. Solve for, you know, I1 from here, you'll get Vx. Fine. So this is, I think, a lot of drilling is there. So what charge? I think the same thing. Let me. And this will be Vx. A 300 microcoulomb in these capacitors. Answer. And 900 microcoulomb in these capacitors. And if this is 300 everywhere, these capacitors will be 300 microcoulomb, 300 microcoulomb, 300, 300. This will be 900 microcoulombs. I just wrote at one of the place. I think that's what he's asking. C1, C2, C3, C4. C1, C2, C5, C6. Let me write it. Capacitors C1, C3 and C4 will be 900 microcoulomb. Cross check the answer. Let me go for next problem.